This is the Section 4.1 Mathcast. It contains 5 lessons. There is a significant amount of material preparation for the lessons in this chapter. See the teacher notes for details. Lesson 4.1 begins with an overview of survey design as students consider question bias in surveys. Students next discover that random selection and sampling is necessary to produce a sample that is representative of the population. They will experience different methods of sampling that include randomness and consider the strengths and weaknesses of each. Students have the opportunity to create and administer their own survey, considering bias and sampling methods. Students will compare and contrast observational studies, where the explanatory and response variables are simply observed and recorded, and experiments, where the explanatory variable or variables are applied and the results recorded. Then use this knowledge to critically analyze conclusions for various real and fictitious studies. Lesson 4.1.5 is an optional day that can be used for team presentations of their survey results. Many students will have had experience participating in surveys, but few will have any idea of the types of bias that are associated with this type of data collection. Asking people survey questions to obtain unbiased information is much more difficult than it seems. Students will see examples of and identify different types of question bias and attempt to write their own research questions. If you choose to do the optional U.S. Classroom Census, it would be a good idea to set up several measurement stations throughout the classroom. If you choose to have your students perform the surveys they design, there will be a prompt in Lesson 4.1.3 to continue work on it. Also, if you choose to have the students give presentations of their surveys, there will be an opportunity in optional lessons 4.1.5 and 4.2.4. In Lesson 4.1.2, students will see that people are poor at choosing representative samples. They will see a direct comparison of person estimated mean values, person hand-picked mean values, and actual random sample means, clearly showing an increase in accuracy and a decrease in variability. This lesson includes a math notes box highlighting sources of sampling bias. You will need to prepare the 3 histogram posters in advance of the lesson. And there are 2 resource pages that go with this lesson. While a simple random sample may not always be possible, students need to always be mindful that random chance be a part of every selection process. This extends to all of their conditions for inference found in later chapters. Lesson 4.1.3 uses collecting data at a dog show as a plausible scenario for comparing SRS to stratified and cluster sampling, with an option for systematic and multi-stage sampling also. You will need to prepare 3 to 5 posters for histograms. There are 3 resource pages required, with at least 1 set required per team. You also need to be ready to explain random number generation on the calculator of choice for your class. Many teachers and students would explain stratifying as a way to increase fairness in a sample. However, nothing could be more fair than a simple random sample, that is, where each person and group has an equal chance of being selected. The true purpose of stratifying is to reduce variation in the sampling distribution. In Lesson 4.1.4, observational studies are defined and their limits discussed. Students are given some research questions to consider and answer questions about their possible designs. Sample or census? If sample, how is it designed? If survey, how is it designed? Possible confounding variables. In this lesson, experiments are also defined. Students are given actual news headlines and are asked to determine whether an experiment or observational study was used and how they were designed. This is obviously an observational study because as an experiment, marital strife would have to be applied at random to subjects of the experiment. As an observational study, students are asked to determine confounding variables. Students are likely to come up with variables that reasonably cause variation in heart disease, such as family genetics or sedentary lifestyle. But these variables are not tied to marital strife necessarily. We're looking for variables that affect heart disease, but are also tied to marital strife. Consider job stress. It could be that people who have very stressful jobs also have marital strife, and perhaps the job stress is causing their heart disease. So job stress is a confounding variable because it's tied to both the explanatory and response variables. Another possibility is substance abuse. Substance abuse may cause marital strife. Also, it might cause heart disease. So it's a good confounding variable because it could be tied reasonably to marital strife and heart disease. If you had your students conduct their surveys and want them to present their findings or highlight a particular team's lessons learned, you can do that in this optional lesson. There is another in-class survey that again illustrates how not random people are in their responses, even when they're assumed to be. For problem 446, you will need to prepare a dot plot poster and have at least 3 sticky dots per team. In this section, the students learn the many challenges involved with survey data collection and compare and contrast observational studies with experiments.